Hello ladies and gentlemen, this is Mr. Kissinger. I'm here. We're going to do another video on box and whisker plots. And box and whisker plots are probably not something you're going to see all too much, at least not right now. They probably might gain in usage the more they're being used in school. They are definitely something that's tested a lot. Parents, you might not have seen this before, or if you had it, it was probably just brushed over real quickly. It is something that's taught quite a bit more. So we're going to do two examples here. We always learn from examples, and hopefully this is helpful to you. So here's some numbers. I got these off the web and the internet, and here's some numbers. And we're just going to make a box and whisker plot with this data here. So first thing we need to do is put these numbers in order. So 11 is my smallest, and I have, looks like, 2 12s. So first put your numbers in order. And I have a 13, 3 14s, 1 2 3, a 16 and an 18 is what I'm seeing here. Now just make sure 1 2 3 4 5 6 7, 2 3 4 5 6 7 8 9 numbers. 1 2 3 4 5 6 7 8 9. Good. I have them all. Now our first step, let's write all these down here somewhere, is find the median. So, and the way I teach students is don't cross them out like I did up here. We need to actually see those numbers for a little bit in this process. So we're going to just find the median, which ends up being 14. I'm going to put an M there. That's my median. And the second step is we're going to find the lower quartile, or also known as quartile 1, Q1. So Q1, first quartile, or quartile 1. And all you have to do there is just think of it. Quartile, we learn, means like splitting it up into 4 pieces or 25% chunks. And so median's the 50% mark, or the halfway mark. We're going to split this data now in half, because half of a half is 1/4. So here we go. 1, boom. Well, I have two numbers, 12 and 12. The number, whenever you have two numbers, you just add them up and divide by 2, but everybody can see the average of 12 and 12 is just 12. So my lower quartile is 12. And if we did the lower, we're going to do the upper quartile. So upper quartile, and that is Q3, or the third quartile. And some students ask, where's the second one? Well, if you think of it, if you have 2 quarters, that's 50 cents, that's your median. So Q2 is your median. So again, we're going to find this right here. It's in between 14 and 16. The number right in between 14 and 16 is 15. Or you could add them up, 30 divided by 2, 15. Either way. The next two are super easy. We just put our lowest number and our highest number. And our lowest is 11. Our highest is 18. Okay, now that we have that information, we can plot it. So, on a number line, and I'm going to go from 10 to 20, 11, 12, 13, 14, 15, 19. We're going to plot our data. What we're going to do is first, let's put our median at 14, and a little bit above it, we're going to put a raised line there. This will all make sense in a second. Lower quartile 15, right there. Lowest is 11, and I will stick one here. My highest is 18. And these middle three, we're going to connect these, and then we're going to so box, whiskers. What this does is it gives you a nice visual representation of your numbers, of 25% of your numbers. So 25% of my data is here, 25% of my data is here, 25% of my data is here, and 25% of my data is here. And the reason this is beneficial is we can really look and see where our numbers are clumped up. So I can see there's a big spread here from 15 to 18. That's a big spread. But I have a lot of numbers really bunched up here in 14 and 15. And sure enough, if you look at our numbers, we have a lot of 14s. I mean, it's exactly what it shows. So especially when it's really large data plots, you can really see some patterns nice and quickly. Another thing that we learned in our book is called the interquartile range. So if you remember from earlier, range is just your highest minus your lowest, your high minus your low. So 18 minus 11, which is just 7 in this case. Interquartile range is how big your range, but just for the box. So it's going to be Q3 minus Q1, which in this case is 15 minus 12, or 3. Just the box is 3 big, is what that's telling you. It tells you that 50% of your data, 25% chunks, so 50% of your data is all within 3. Now let's do one more example. So, very, very similar. I'm going to do this one again just to make sure we have it. So, first thing, put these numbers in order. So I see an 11, there's a 12, 14, 2 of those actually. There's a 15, 2 16s I'm seeing, an 18 and a 19. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Just happens to be 9 again. You know what? Let's just throw in 20. I'm going to throw in another one just to make it different, so we're not doing 9 again. This time we have an even number, just to make things different. Here, I'll throw 20. There we go. All right. So again, first step, we're going to find the median. Median's your middle number. So 1, 2, 3, 4. 1, 2, 3, 4. Right in between here and 15 and 16 is my median. So that's going to be 15.5 is my median. I'm going to write that number down. My second thing I'm going to do is find the lower quartile, or Q1. So we're going to find the 50% of just this chunk here. So that's 1, 2, 1, 2. Right here, my number is 14. That's going to be Q1, 14. And on the other side, it's going to be our upper quartile. 1, 2, 1, 2. Right there, it's 18. Q3, 18. Last two steps. My lowest number is 11. My highest number is 20. Alright, let's plot that again real quick. So, I'm going to put numbers down just as before. 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. You know what, actually I'm going to change this just a tad. And I'm going to put those numbers on this graph. So I'm going to refer back to these numbers here. And I'm going to put these on here, on the same one, so we can compare them real quick. And so the median of this one was 15.5. So right here, I'm going to put this down below it, 15.5. The lower quartile was 14. The upper quartile was 18. My low number was 11. My high was 20. 11, 20. So we have all of our information we need. Going to make our box. Again, those 3 in the middle. And then right there we're going to have our whiskers. So this one here, our range, high minus low, is going to be 9. And our interquartile range, the size of this box here, goes from 18 to 14. So it's 4. So what we can see on this one, just looking at our second box of whisker, is it shifted to the right. Shifted to the right here. In fact, I could make an argument that 1, 2, 3, 75% of my numbers are larger than 50% of my numbers over here. And we can make that argument using this here, because there's 1, 2, 3 chunks. 3 25s is bigger than 2 chunks up here. So 75% of my numbers is bigger than 50% of my numbers here. There's a little, or that 25% of my numbers occupy the space here, that 50% of my numbers here do. And so you can make arguments like that because of box and whisker plots, and it's a nice way of comparing things. we're going to be using that for our project coming up soon. Thank you guys. I hope this was helpful. Talk to me in class if you need extra help. Thank you. Bye.